Hello. Today we are presenting the existing risks of generative AI, mapping the who, what, and how of real-world incidents. I am Wendy Bickersteth.
And I'm Megan Lee.
And we are working in collaboration with many other likely very familiar names.
Okay. All right, so as I'm sure we're all aware, generative AI is everywhere. It's in our browsers, it's in our AI girlfriends, and so while it's garnered lots of excitement, it's also garnered concern that it poses risks. And some of these have already caused harm in the real world, as we'll see on screen here. So it's resulted in fake citations being brought to the courtroom. It's being used to stir up misinformation about the war in Ukraine. And it's been used to make a lot of non-consensual intimate imagery. So these risks, the ones that have already been observed in the real world and caused real world harm, are called existing risks. And the goal of our work here is to better understand these so that we can address the harms that are already present in deployed AI systems. So in this work, we contribute a coordinated taxonomy that not only maps the real world harms of generative AI, but also traces them to how they arise and who they affect based on our analysis of 499 publicly reported incidents, which we take as real world incidents of harm.
So to approach this project, we created a conceptual framework that maps harm from source to impact. We believe that an issue starts with a sociotechnical failure, which is the underlying technical or user factor that led to some harm, an outcome that negatively impacted people and their interests. The people in this case is the stakeholder, the human entity that could have been or was harmed. And so to collect incidents, we scoured two online repositories, the AIAAIC, I always get that wrong, and the AIID. To search through these repositories, we looked for any incidents involving generative AI, so we used the term generative AI generally. We also searched for specific outputs like deepfakes. We deduplicated, and we had a resulting data set of 499 incidents. So to show how we applied our conceptual framework, we will go through an incident. In this case, we have the case of a Colorado lawyer filing a motion citing hallucinated ChatGPT cases. So we first have the failure modes. The most obvious failure mode here is hallucination, but there is a second failure mode of improper use. We define improper use as using or deploying generative AI to complete tasks that typically require a professional license, it requires training, or it's subject to industry standard, but the user did not properly review outputs. And as a lawyer, we do expect them to do their due diligence and look through their cases, thus improper use. Then we have the harms. Reputational is also another more obvious harm that occurred here, especially for the lawyer. But there's also human rights and civil liberties harm. So the lawyer faced legal repercussions, but the client was also legally impacted because the integrity of their case was in question. Lastly, we have the stakeholders. The end user is the lawyer, and the individual beyond the end user is the client.
All right, so now we'll get into our findings. So we're first going to present our coordinated taxonomy, which is made up of 3 parts. So we have a taxonomy of sociotechnical failure modes, a taxonomy of generative AI harms, and a taxonomy of harm stakeholders, which we'll present alongside a quantitative representation of how they relate to each other. Okay, so first we'll introduce our taxonomy of who was harmed. So there are 2 high-level categories that we're going to identify here. So first, there are interacting stakeholders. So these are people who knowingly choose to interact with a generative AI system. So these are the end users or the developers and deployers. And then there are non-interacting stakeholders who do not necessarily choose to or even know that they're interacting with a generative AI system. So these are third parties beyond the end user, such as the unknowing subjects of a deepfake, communities, and society. And so now we introduce our taxonomy of generative AI harms. It is organized into these 12 high-level categories, ordered from left to right based on how frequently they occur in our incident data set. And then there are these 41 specific harms, each falling under exactly one category. And we won't get into the specifics here, but the saturation of the color of each box indicates its relative frequency in the data set. So the most common type of harm overall was harms to people's autonomy, followed by political and economic harms. And the single most prevalent harm was impersonation or identity theft. So here we're looking at the relationship between harms and stakeholders. So in particular, each bar here represents how many incidents of harm there were to that type of stakeholder. And we label the type of harm that most frequently affected each type of stakeholder in the bar. So the non-interacting stakeholders, which are bolded and highlighted here, were by far the most frequently harmed type of stakeholder in our data set. And they were mostly affected by autonomy harms, whereas interacting stakeholders were largely affected by harms to their reputation or informational harms. So since this is a privacy conference, we wanted to look a little bit closer at privacy harms. So based on our analysis, they mostly affect end users and individuals beyond the end user. And these are generally incidents of exclusion or disclosure. So basically when people are excluded from decisions concerning their own data, or when personal data is improperly revealed or shared by generative AI. And finally, we introduce our taxonomy of sociotechnical failure modes of generative AI. So it's organized into these 4 high-level stages of the AI lifecycle, which are the design, the development and evaluation, the release and use. And there are 14 specific failure modes, each falling under exactly one stage. And again, the saturation of the color of each box indicates its relative frequency in the data set. And the most frequently appearing type of failure mode was use-related, meaning that it arose due to the use of a generative AI system. And the single most prevalent failure mode was malicious use. So when someone uses a generative AI system for malicious purposes. And here we're looking at the relationship between failure modes and affected stakeholders. And again, each bar represents how many incidents of harm there were to each type of stakeholder. And here they're split by the type of failure mode associated with the harms to each stakeholder. So as we can see, use-related failure modes tended to affect non-interacting stakeholders, whereas development and evaluation failure modes tended to affect interacting stakeholders. Okay, so finally, we're looking at the relationship between failure modes and harms. And so each bar here represents the frequency of that type of harm in our data set. And within each bar, we indicate the top 2 failure modes contributing to that type of harm. So for example, at the top, autonomy harms were most often associated with malicious use and problematic data collection and processing. And in fact, malicious use was the top failure mode contributing to political and economic harms, psychological harms, representation and toxicity harms, and financial and business harms.
So time for the fun part. We're going to look through some examples. So the first incident displays autonomy and privacy and security harms. And just for your reference, harms that were heavily altered from prior work or were surfaced by us are indicated by an asterisk. So in this incident, we have OpenAI being, well, I won't say accused. The New York Times reported that OpenAI scraped YouTube videos without permission to train its models. So first we have IP copyright issues because the YouTube creators were not informed or compensated for their videos being used in their models. Additionally, we do have a secondary use concern because one could assume that YouTube creators did not upload their videos knowing that their videos will then be used to train a model. So there was a secondary use to their video. The affected stakeholders are the YouTube creators, so the individuals beyond the end user. And then the failure mode is problematic data collection and use. We define this failure mode as when AI developers indiscriminately collect and or use data, preventing users from giving informed consent on how their data is used. The second incident displays financial and business and privacy and security harms. So between 2018 to 2021, 2 scammers generated deepfake videos from high-definition photographs to simulate facial movements to then bypass government facial authentication. They then created tax invoices, fake tax invoices, and defrauded the Chinese government of 76.2 million USD. The specific harms here are financial loss and cyber attacks, both affecting the Chinese government. So the affected entity is an organization beyond the end user. And the failure mode is malicious use, which Megan already pointed out is our most prevalent failure mode. Then lastly, we have an incident that's an example of exclusion. A mental health nonprofit, COCO, conducted an experiment that provided mental health counseling using an AI chatbot, but it didn't adequately disclose that to 4,000 users. COCO also did not get IRB approval, which I'm sure to many of us in this room is extremely concerning. Therefore, the users were excluded from giving informed consent, and the failure modes are problematic data collection and use, but there's also undisclosed or unwelcome use. So we define this failure mode as when generative AI is used in a setting where there's an expectation of human creativity, human labor, expertise.
Okay. So unfortunately, our work is not perfect. It does have some limitations. And so first, well, because we relied entirely on publicly reported incidents as empirical data, well, both of these incidents define both of these repositories define an incident as a single event. So harms with a cumulative nature, so many environmental harms, won't appear despite the fact that we all know that generative AI is sucking up lots and lots of natural resources every day. And second, a lot of harms may be over or underreported due to reporting bias. So incidents that are sensational, such as deepfake impersonations, or affect well-resourced groups, such as celebrities, may be overreported, while incidents dealing with the design or development of generative AI, such as having to do with data acquisition or the implementation of safety guardrails, may be underreported. And we hypothesize that this means that privacy-related incidents are probably underreported. So now we're getting into some of the key takeaways from our work. So first, the distribution of benefits and harms of generative AI is uneven across its interacting and non-interacting stakeholders. So most of the benefits of generative AI, so like increased productivity, the revenue, are accruing to its interacting stakeholders, whereas at least based on our work here, most of the risks of generative AI are affecting non-interacting stakeholders. And so this erodes one pathway of accountability that's often assumed in technology governance frameworks, which is basically that if you're choosing to use a technology and participate in its benefits, you must also assume some risk of harm. And that doesn't seem to really hold true here. So this is actually also true in data privacy, where the people that are choosing to collect everyone's data don't assume very much risk, but reap a lot of the benefits, whereas the people whose data is collected, they don't benefit quite as much, whereas they assume most of the risk. Okay. So the second key takeaway is that generative AI seems to change the landscape of AI harms. So some of our key findings are different from prior work analyzing AI harms more broadly, so including traditional AI systems. So prior work has not found malicious use to be a common cause of harm, while we found the opposite. And prior work also found that direct users of AI tended to experience the most harm, while again, we found the opposite. And so this suggests that AI governance isn't necessarily application specific, and in particular, it's probably distinct between traditional and generative AI. So we have a couple of recommendations based on our work here. So first, we argue that basic AI literacy can reduce certain risks of harm. So as we mentioned earlier, there are these cases where lawyers bring hallucinated court cases to court. And that's a case of both hallucination on the part of the AI, but also improper use on the part of the lawyer. And we argue that we only need to prevent one of these to have prevented the harm. And so one obvious way to minimize improper use is to ensure that people know about the basic capabilities and limitations of generative AI. So making sure that people know that they can hallucinate. And so one idea as to how to accomplish this is standardized safety labels for generative AI applications. And the Internet Safety Lab folks gave a great overview of what safety labels are earlier. But essentially, they'd be standardized labels disclosing the risks of using a particular app. So something like the security and privacy labels on screen developed in Scilab. Okay, so our second recommendation is that work is needed to address the limitations of this study. So longitudinal studies are likely necessary to address cumulative harms. And confidential incident repositories, such as that being developed by MITRE, is probably needed to address reporting bias. But seeing as generative AI is increasingly a consumer product, we need to think about how we can encourage end users to engage in incident reporting rather than just the engineers or the researchers. So, yeah.
Thank you. Please look at our paper.